All right, we have talked a lot about sine, cosine, tangent to be able to figure out the length of a side or the length of an angle. Now we're going to do this with triangles that are not right triangles. So if you see right here, we have a non-right triangle, and we're going to use law of sines, which is slightly different than just the sine, to find unknown sides or unknown angles. So what we're going to do first is kind of discover this formula. So we're going to follow these directions. We're going to sketch an altitude from B. Who remembers what an altitude is? It's like the height of the triangle. It also, altitudes always meet the other side at 90 degrees. So basically we're taking this and we're making it into two right triangles. Okay? And we're going to label this altitude K. We've got little side A, little side B, little side C. We've got angle A, B, and C. And now we've got side K. The altitude creates two right triangles inside ABC. Notice that angle A and angle C is contained in those triangles. Using right triangle trigonometry, we're going to write two equations, one involving sine of A and one involving sine of B. Okay, so if I'm looking at A, sine is what again? O, which stands for opposite over? Okay, so if we're looking at A, what's the opposite side of A? K. And what's the hypotenuse in just this triangle? C. So it's K over C, right? All right, for sine of C, you guys tell me what that is. If we're looking at C, what's opposite of C? And what's the hypotenuse for just that side? For just this side? A. Okay? All right. Notice that each equation in question 3, are we okay, guys? We're focused? Yeah, I can zoom in. It's all good. Okay, notice that each equation involves K. Why does this happen? Solve each thing. It involves K because K is the opposite of both of them, right? I'm not going to write that down. I'm just discussing why it happens. And we're going to solve this for K. So I've got sine A equals K over C. I want to get K all by itself. So what am I going to have to do? Multiply both sides by C. These cancel. And I get C sine A equals K. Okay? Let's look at that other side. I'm not moving. I'm not moving. I'm just writing this down right here. And I want you guys, if you're done writing this part down, to solve this one for K. Same way. Okay, so how did you do this side? Multiply by A, so we get A sine C equals K, correct? Okay. Step 5. Are they both of these equations equal to K? So what am I going to do? Can they be set equal to each other? They're both equal to the same thing, so I can make them equal to each other. C sine A equals A sine C. Questions, comments, concerns? Okay. Notice that the equation in 5 no longer involves K. Why not? Because they were both equal to K, right? And we didn't need to have the K in there. Write an equation equivalent to it, regrouping A and C. Okay, so this is where it gets a little weird. I've got little c sine A equals little a sine C. I want the A's all on one side and the C's all on the other. How am I going to get this A right here to this other side? Divide it. Divide it. Okay, so now I have little c sine big A over little a equals sine C. I want this C to go to this side. What do I need to do to it? What's the opposite of multiplication? Division. So I'm going to divide both sides by little c. So I'm left with sine A over little a equals sine c over little c. I'm not sure why we're talking in the back. Are we confused about something I'm writing?
Wait, is that an A or a C?
Right here, that's a little a. Sine big A over little a equals sine c over little c. Excuse me? We okay? Questions? I'm never going to have you do this on your own where you're going to have to find the equation. I'm proving to you right now that the equation can be found using right triangles and sine and cosine. You're going to have to apply this equation, but you're not going to have to find it like we're finding it right now. But it's important for you to see where it's coming from. Big one's next to the sine. Little one's next to it. Okay, let's turn it over and we're going to do almost the exact same thing. Okay? First thing we're going to do is we're going to draw an altitude again, but this time we're going to draw it from C. Yep, always from one side to the other. That's my altitude. Altitudes meet the other side at 90 degrees. So far, so good. It should look really similar to the last one. We're going to label this side K. So far, so good? Okay. Now we're going to do the same thing. Sine of A, so if we're looking at A, what's opposite A? K. And what's the hypotenuse for just this side? B. So we're going to say sine of A is K over B. And then we're going to do sine of B, what's opposite B? K. And what's the hypotenuse for B? A. Okay, we're going to solve them for K again, just like we did on the other side. Sine of A equals K over B, and sine of B equals K over A. How do I get the B to the other side again? It's being divided, so I'm going to... What's the opposite of multiplication, guys? Division. What's the opposite of division? Oh, there we go. So we'll multiply B on both sides. So little b sine A equals K. And what are we going to do over here? Times by A. So we can get K all by itself. Little a sine B equals K. Okay, my next question. Do they both equal K? Can I make them then equal to each other? Yes. Little b sine A equals little a sine B. Okay, so we want to do the same thing we did for the other one again. We want to get all the b's to one side, all the a's to the other. So what's the opposite of multiplication? Division. Okay, so I'm going to move little b first, because it really doesn't matter. You could move little a first, so you get the same results. Divide both sides by little b. I get sine A equals little a sine B over little b. How do I get rid of that little a? Divide. And I'm left with sine A. Please stop talking. Unless you have a question, then I would love to hear it. Sine A over little a equals sine B over little b. The little ones should be, the little ones should be on the bottom. The little ones are the sides. The big ones are the angles. Little ones are the sides. Big ones are the angles. Now, what we're going to do for this one is we're going to put all of them together. We're looking at sine A over little a equals sine B over little b. Yep. Equals sine C over little c. And now I'm going to do some examples of how we're going to use this. You're never going to have to go through like I just did and figure out, discover the problem, discover the equation. I want you, I want you to have this so you know where we're coming from and why it works. So I took a non-right triangle, made it into two right triangles to discover this formula. So now I know I can use this formula for any triangle. And now we're going to go through a couple of them. So we're going to look at your homework. This is going to mean you have less homework to do because I'm going to do some of them. Okay? So this equation right here is written right at the top of your paper. And see how there's three? There's sine A over little a, sine B over little b, and sine C over little c. We're just going to use 2 out of the 3. We're just using 2 out of the 3. So if we're looking at number 1, this is big C, so this has to be little c. This is big B, so this is little b. And we're trying to find little b. Okay? We're trying to find little b. So how would I find what C is? I've got 2 of the angles. How would I find that third angle? It's a triangle. What do the interior angles of a triangle add up to be? 180. So if I take 180 minus 118 minus 22, I can get that this is 40. And I think probably on this problem, you should write down that we did 180 minus 118 minus 22 to get 40, just so that you remember where that came from. I don't care if you do most of that work on your calculator and don't write it down, but write it down this time so you remember where I came from. Okay, now I am looking for little b. This is what I have to find. So I'm going to have to use angle B. And right here I have little c, so I'm going to use angle C. So this is what my problem is going to start with. I'm going to have sine of big B over little b equals sine of big C over little c. Okay, so the first thing is to figure out what you're trying to find, and then you want the opposite side and angle. So nope, now we have to actually plug in the numbers to do it. Okay. I know this is, you can't do this on this paper. You definitely, at this point, I would move to a separate piece of paper. Is your best bet. Okay? You can use the back if you don't want to get up and get paper. But so, shh, you cannot have side conversations while I'm doing this. We do not have that kind of time. Okay, so I'm going to put sine 22, because that's my b, over little b. That's what I don't know. Okay? And then I'm going to have sine of C, which is 40, over little c, which is 24. Okay, now how would I solve this now? I've got a fraction over a fraction, and I have one unknown under the fraction. You are going to cross multiply. I'm going to go 24 times sine of 22 equals b times sine of 40. How would I get b by itself? B is being multiplied by the sine of 40, so I need to divide. Good. So I'm going to put in my calculator. 24 sine 22 divided by sine 40. And I'm going to get 13.98 equals B, and you're finished. All of that for one problem. Okay. I would like to do one more with you before you guys work on this on your own. Because this is an example if we're trying to find a side. I would like to do an example where you have to find an angle. Because it's slightly different. So I'm going to move all the way down to number 9. Does everybody have this before I move to 9? Yeah? Okay, I'm going to move down to number 9. Number 9, I need to find angle A. Okay? This right here is little a. What other angle do I have? C. So I'm going to have to use little c.
How do you know it's C?
How do I know that this is for C, not B? Because it's slightly to the side. So I know it's C. It would be more centered if it was B. In most of the triangles, you can tell this is a funky triangle, so it's harder. But this is C. Okay, so I'm going to write it down. I'm going to go sine of C over little c equals sine of A over little a. Shh. Jeez, guys. So I'm going to put sine of what? What goes here instead of C? I'm going to put what? 129. Over what's little c? 25. Equals sine of A, I don't know that. What's little a? 11. And now what am I going to do? Cross multiply. So I'm going to go 11 sine 129 equals 25 sine A. If I wrote 25 sine A equals 11 sine 129, would that be the same thing? Yeah. So now I can only divide, please stop talking. I can only divide by 25. And then I'm going to put all of this in my calculator, and I'm going to get sine A equals, and I'm going to put in my calculator. I like to hit control divide, and it gives me that funky fraction. And I put in 11 sine 129 over 25, and I get 0.3419. There is one more step I need to do. What would it be? I've got sine of A equals 0.3419. What am I going to do to get A by itself? Inverse sine. So I'm going to get A equals inverse sine that number. And then I'm going to get what angle A is. So I'm going to push my trig button, inverse sine, 0.3419, and I get 19.9. Or you could round up to 20 degrees. Okay, so I've given you two examples. One where you find a side, one where you find an angle. You just have 8 problems for homework, but you guys have got like over half an hour to work on this in class. I'm leaving the answer key with Mr. Kwan. So he can, if you're stuck on something, he can look at it.
I can figure this out. I know how to do this.
And we'll be good.